This is written in P upon Q formula. Like in the ninth standard, you have studied that if you have velocity and time graph, then velocity upon time give you acceleration. Similarly, whatever here V is potential difference and I is current. Okay, so you will see here that V upon I will gives you the resistance, and that will be equals to tan theta. More the value of theta, more will be the, if we have two or more graphs here on the same point, you have R1, R2, and R3, more the theta from the I, okay, theta from the I, more will be the resistance. But here we don't have VI graph, we have IV graph. So theta will be always measured from I. So here the theta is 1, theta 2, and theta 3. Okay, so we'll say that the resistance R3 will be greater than R2 will be greater than R1. Understood? Understood, everyone?
Yes, sir.
Okay. Okay. Do this question. Just a minute. That's which questions I have given you from the NCRT example. I have given you some questions. Let me check that how many questions I have given you. Just a minute. NCRT example 21, 22, 23, 24, 21. Okay. This what should be the answer for this question number 21?
So the answer is low because ammeter used in series and in series resistance is low.
Yeah. So you can simply say here that if you are having a resistance, because you know that ampere meter is always connected in series. Okay, when we are having ampere meter, and ampere meter should always be connected in series. Okay, and as you have noticed, just a minute, okay, okay, and you know, if we are having high resistance in series, okay, then the current will not be passing through the resistors, because resistance offer the means opposes the flow of current. So if the ampere meter is going to have high resistance, then it will block the current of all the circuits of the all the components. So it will not be, means that's why the resistance of emitter should be low. Okay, you understood? Understood?
Yes.
And do question number 22. Do question number 22. Now you done this one, everybody. 22. Will you able to draw the circuits? Tell me, everyone. Jobita, is I'm audible to you?
Yes.
Why not speaking? Okay, do you draw this one? Will you able to draw this one? This is very simple questions. Draw the circuit of the diagrams of electric circuit containing a cell, a key, an ampere meter, and a resistors 2 ohm in series with a combination of four with the two 4 ohm each resistors in parallel. So it is a 2 ohm resistors and with the two 4 ohm resistors in parallel. Okay, got it. And in parallel and a voltmeter. Okay, this voltmeter, where should be the voltmeter be connected? Okay, and the voltmeter across the parallel combination. So here it should be the voltmeter. Okay, and where should the ampere meter, you can connect either here or here, anywhere you can connect the ampere meter. It's not a big deal. Okay, got it. So you can connect the ampere meter here and a key here and like this way. Okay, this is the circuit. This is 4 ohm, this is also 4 ohm, and this is 2 ohm. Got it?
Yes, sir.
Here it is asking that will the potential difference across 2 ohm resistor will be the same across the parallel combinations of two 4 ohm resistor? Will the potential difference remain same? Tell me. It is asking that if you have the value, like if you have the value like this way, if you have a voltmeter V1, okay, and if you have the voltmeter V2, so will there be difference in the reading? Will you observe any difference in the reading? Tell me. Will you observe any difference in the reading? Anyone in the class? Is Abir is there in the class? Yeah, Abir, can you tell me? Will you observe any difference in the reading in the V1 and V2 voltmeter? Abir, are you there? Your voice is not audible to me. Just a minute. You speak something? Jobita, are you there?
Yes, sir.
Your voice is coming. Abir, I think you are not there in the class. So let me solve this one for you. That what is there any difference in the reading or not? Will there be difference in the reading or not? If such type of questions comes in examination, then what you are going to deal with? Okay. So just a minute. Let me bring the screen here. Okay. So in this type of questions, when you are having such type of question, this is very simple questions. Like you see here that in this question, stop, that you have a 2 ohm resistor here and a 4 ohm resistor here. 2 4 ohm resistor here. Okay. And I'm just asking you that they are connected with some potential difference, whatever it be. I'm asking you just is there. This is a 2 ohm resistor and this is a 4 ohm resistor and this is a 4 ohm resistor. Don't, and this is a V1. I'm asking, this is a V1 and this is V2. Or anyone can be V1 or V2. I'm asking, is there any difference in the voltmeter? So we'll say no, there will be no difference. Why? Just imagine. Don't think these are the two 4 ohm resistor. Just imagine that this is a 2 ohm resistor and it is connected with V1 voltage. Okay. And this is another 2 ohm resistors, because you know that if two 4 ohm resistors are connected in parallel, then their equivalent resistance will be 2 ohm. 1 by 4 plus 1 by 4, that will be equals to 4 by 2, that is 1 by R equivalent. So that will be equals to, that's your reciprocal this one. So you will also reciprocal this one. So R equivalent will be 2 ohm. So for this one, these two resistors, we have equivalent resistance as 2 ohm. So this is 2 ohm and this is also 2 ohm, and they both resistors are same. So when you know that in series the potential difference divide. In series the potential difference divide. But if the potential difference, let's suppose here is 10 volt. Okay. So if the resistors are same, then this will receive 5 volt and this will also receive 5 volt. If the resistors are same. If the resistors are same, then the equal potential difference will be there. So there will be no change in the potential difference across this 2 ohm resistor and this 4 ohm. Because they are the two 4 ohm resistor, but they will be going to receive equal, because you don't consider this one as a 4 ohm and 4 ohm. They are actually 2 ohm resistor. Just imagine this is a single resistor, okay, of 2 ohm. So whatever the answers you get for the 2 ohm, that would be also for the 4 ohm resistors. Understood? Is there any doubt regarding to this question? Tell me fast, everybody, why you're not answering?
No, sir.
Clear? Everybody in the
Yes, sir.
class? Madiha, Samar, Shweta,
Yes.
Jovita, Adil,
Yes.
Abir, Charisma, everyone understood? Okay.
Yes, sir. Yes.
So whenever they are the two types, two or more type of resistor, they are connected in parallel, just consider them as a single resistor. Okay, got it? Now I'm just having for your knowledge. If I'm having, suppose, if I'm having a 6 volt, okay, 6 ohm resistor here, and a 2 ohm resistor in parallel, okay, and a 3 ohm resistor here, okay, and a 5 ohm resistor here, okay. which of the following resistor among this 2 ohm, 3 ohm and 5 ohm, that let if they are connected in, if they are connected with 20-volt battery, which of the following will receive the highest potential difference? Which of the following will receive the highest potential difference? Can you tell me? Which of the following will receive the highest potential difference? Tell me which of the following will receive the highest potential difference in this case.
Sir, the 6 ohm resistor.
According to you, 6 ohm resistor will receive the highest potential difference. Okay. If I'm saying that, let assume that this is a 6 ohm resistor. Okay, 6 ohm resistor. And you know, just don't think there are three, because in parallel potential difference remains same. Whatever the potential difference this will receive, this will also receive, this will also receive. Just 2 ohm resistor means less power. Like for example, a 220-volt bulb, sorry, a 50-watt bulb, a 60-watt bulb, or 100-watt bulb. Okay, so you can assume it like this way. But if you are connected with the main source, they will receive the same potential difference. But the thing is that if I'm asking that which of the following will receive the highest potential difference, so let's make an equivalent resistance of this one. What these three resistors are going to have? Okay, this is 1/2, 1/3, and 1/4. The equivalent resistance of these three. You can take the LCM as what you can take the LCM 10, 30, 20, 21, 30. 30 is the LCM. Okay, 30. This will be 15 plus 10 plus 6. Okay, 25, 25, 31 upon 30. Okay, so you reciprocal this one, you will get 30 upon 31, you will get 0.9 something. You got this one? The equivalent resistance of these three will be 0.9, means less than 1 ohm. Okay, just for instance, just let's assume that this is 1 ohm resistor. 1 ohm, this is 6 ohm, this is 1 ohm. And now you know that the resistors, if the current is same, you know that whatever the current of the circuit is in series, it will remain same. If the circuit has 2 ampere current, then the 2 ampere current will flow in this one and in this one also, means the current remains same in series. Current remain same in series the current remains same. So whatever the value of the current is, it will remain same in this one and in this one. And I'm again saying you that don't think that these are the three resistors. Don't think that these are the three resistors. Just assume that this is a single resistor. And calculate it equivalent resistors. Equivalent resistance 2 ohm, 5 ohm, and 3 ohm, whatever these three resistors. So they will have 0.9. I'm just writing it 1 ohm approximately. Okay, approximately. So this 6 ohm and this is 1 ohm. Whatever the current this circuit is going to have, equivalent current, the same current will flow in this one and in this one. Because in series, the current remains same. Current does not change. Okay. Now you know that V is equals to I into R. Now, if I say that this number is constant, so more the resistance, more will be the potential difference. We will say that V is directly proportional to R. More, if the current is same, current is fixed, this and this is same. So more the, like for example, let's just explaining you, just I'm going to explain you. Let's suppose 1 ampere is the current. 1 ampere is the current of this flowing in this circuit, 1 ampere. So 1 ampere current will flow in this one and 1 ampere current will also flow in this one. So now you know that if I ask you that what is the potential difference across this one, V is equals to I into R. So V is I said that is 1 and this is R will be 6 ohm. This will be 6 volt here. And similarly, V is equals to, in this one, there is 1 ampere current will flow in this one, and also resistor is 1 ohm. So 1 into 1, 1 into 1, you will get 1 volt. So in this one, 1 volt will flow. It will in this one, 6 volt will flow. Now you know that, dear student, just consider here. This is a very simple trick that I'm going to explain you. That more the resistance, more will be the current. Sorry, more will be the potential difference. More the resistance in series, you have to write in series. More because you know that current remain constant. So in series, more the current, more the resistance, more will be the potential difference. More will be the potential difference. Okay, potential difference. Okay, you understood this one, this concept? Is there any doubt regarding to this topic? Tell me fast. Is there any doubt regarding to this topic?
No, sir.
Okay. Now moving to this part here, that in series, more the resistance, more will be the current. Now you know that. Now you know that if I'm having a 6 ohm resistor here, and if I'm having a 2 ohm resistor here, and 3 ohm here, 2 ohm here, and 5 ohm here. Okay. So whatever the value of this resistance will come, it will be less than the smallest when we have n number of resistors connected in parallel, like 2 ohm, 1 ohm, then another is 1 lakh ohm, another one is 10,000 ohm, 10,000 ohm, 500 ohm, 500 ohm. Okay, whatever the value, when you calculate it equivalent resistance, it will be always less than the lowest resistance. The lowest resistance is 1 ohm. So the answer of this equivalent resistance will be less than 1 ohm. So you can consider that whatever the answer you get, you will get less than, in this case, you will get less than 2 ohm, because the 2 ohm is the smallest resistor. And you know that across, now in the 2 ohm resistor, and you imagine that it is a 6 ohm resistor and there is 2 ohm resistor, 6 ohm and 2 ohm, but you know that it will less than the 2 ohm. We got 0.9, but 0.9 is less than 2. So just imagine that it is a 2 ohm resistor. So you know that which resistor is going to get the highest potential difference. So more the resistance, more will be the potential difference. You understood that this 6 ohm resistor will get the more potential difference. Are you understood? Understood? Now,
Yes, sir.
if I ask you a simple question here, that that okay, we consider that this will get the, for example, we have 7 volt battery. So we calculated that this was receiving 6 volt, and the equivalent of this one was receiving 1 volt. So may I know that out of these three, which will receive more potential difference? This out of this 3 ohm, 2 ohm, and 5 ohm, which will receive more potential difference?
First one.
All of them will receive in same, because in parallel the potential difference is same. So whatever the value you get for equivalent resistance of this one, you get 1 ohm, 1 ampere, sorry, 1 volt. That here you get 1 volt na? When we just consider this one is 1 volt. So all the resistors will get 1 volt, 1 volt. Okay, 1 volt. Let me teach you one simple thing here, dear student, that in series and parallel combination, what you used to do and what you think about the resistors when you are solving the series and parallel combination. Let me teach you very simple trick. That, for example, if I'm having a 5 ohm two resistors, okay, 5 ohm two resistors, and they are connected in series. So whenever they're series, they are connected, just assume that there is a single resistor of 10 ohm, 10 ohm, and whatever the value you get in this 10 ohm, in this 10 ohm, it will be same if you have 10 ohm resistors, 10 resistors. Okay, you know that in series the current remains same. So don't think that why it is saying that the current remains same, because in series it simply means that you are having n number of resistor of that part. Means if it is 10 ohm, so you can imagine 10 a 1 ohm resistor, you can imagine 5 to 2 ohm resistor, you can imagine 255 ohm resistor. It's your choice. Okay, the current will remain same in all, whatever. For example, if you have a 10 volt battery here, and this is a 10 ohm resistor, so what will be the current? So you know that V is equals to I into R, then I is equals to V by R. So you write 10 upon 10, you will get 1 ampere. Even if you do 0.5 ohm, then 0.5 ohm, and you add 20 resistors such of 0.5 ohm, they all will receive 1 ampere current, because this simply means you add up whatever the value, you put it as an equivalent and you will get the value. And similar for the parallel case. In parallel, if you have suppose a 5 ohm resistors, 5 ohm resistor here, okay, and you are connecting it with a 5 volt battery. If I ask you that what is the potential difference in this one. So you know that it is directly 5 ohm resistor and it is connected with 5-volt battery. So it will receive 5 volt. Only one resistor it is, so it will receiving 5 volt. If I ask you that if there are the two 10-volt, two 10 ohm resistors, 10 ohm resistors, and they are connected in parallel. They are connected in parallel. So now it is still 5 ohm. Okay. It is still 5 ohm. Don't think they are the 2 10 ohm resistors. They are still 5 ohm. Because you know that 1 by 10 plus 1 by 10, you will get 10. Okay, 10 by 2, you reciprocal this one, you will get 1 by 5. Reciprocal this one, you will get 5 ohm. If I told you that if you have 25 ohm resistors each, okay, 1 2 3 4 5, each is of 25 ohm, 25 ohm, 25 ohm, 25 ohm, 25 ohm. So, and if you are connecting it parallel with the 5-volt battery, so it is not 25 ohm resistor. Actually, you calculate it, you will get a 5 ohm. And when you receive the 5 ohm resistor, whatever you get the value, the potential difference will be same in all cases. So in parallel, potential difference remains same. In current series, in series, current remains same. Okay. Is there any doubt for this question? Anybody? You understood the previous question that I was explaining you? Tell me fast.
Yes, sir.
Okay. Let's move to the next part of this question. Just a minute. Okay. So here we have this questions on your screen. Let the next question that I was just thinking. Just a minute. The next question for this one, because students, most of the students means they are not able to do the exemplar questions. So that's why I'm just dealing with that one first. 20 after 20, yeah. You know this question 25, the answer of this question 25. What is the commercial unit of electrical energy? And represent it in joules. Do you know? Anybody in
Sir,
the
are
class?
you asking the value?
Yeah. Value also. And what is the commercial unit?
Sir,
The kilowatt.
kilowatt hour is a commercial unit and
Yeah.
value is 3.6 into 10 to the power 6.
Yeah. Kilowatt hour. Kilowatt hour is the commercial unit. We represent it in the simple form kWh. Okay. What is the unit for power? In energy is power into time. Power, you know that work done is equals to power upon time. Okay. Sorry. Power is equals to work done upon time. Okay. So now this if you know that work done will be equals to power into time. This will be power into time. And if I took the standard unit for joules, so power is taken in watt and time is taken in second. So watt second will gives you the energy for the work done. Sorry, unit for the work done, and work done is energy, because work done is also energy. Both have the same unit joules. So watt second. Okay, watt second is the unit for this one. Okay, got it? Got it? Watt second. Now, if watt second, this watt second is also called joules. This watt second is also called joules. But if you know that watt is very simpler unit, 1 watt is very smallest unit. So if we convert this watt into multiplied by 1000, it will convert it kilowatt and take time in hours. So 1000 watt and 3600 seconds. When you take this as a single unit, it will gives you can convert it 3612345. Okay, watt second, and that is equals to, you can call you can write it 1 kW, 1 kilowatt, and this you can write it 1 hour into 1 hour. So this will gives you 1 kilowatt hour is equals to watt second means joules. Watt second means joules. So you can write it 3612345 joules. So that would be equals to 3.6. If you place the decimal here, 6 digit, it will be 10 raised to 6, 3.6 into 10 raised to the power 6 joule. Okay, 1 kWh is equals to. Now you understood, everybody in the class?
Yes.
Is
Yes,
there
sir.
any doubt? No?
No.
Okay. Okay. If I next question, do question number 28. 28. How many of you have done this question number 28? I have not given to you. No? After 25, then 24 I have also given 24. 24. What is electrical resistivity? Tell me. What is electrical resistivity?
The ability of a material to resist conduction.
No. Yeah, we can say that the ability of the material to conduct the to oppose the flow of current, but it is resistance. What is the difference between resistance and resistivity? What is the difference between resistance and resistivity?
Resistivity is the ability of the material.
And what is resistance? What is the difference between resistivity and resistance? So let me explain you that what is resistivity and resistance. Just a minute. So you know that if I talk about the resistivity and the resistance, so resistance is the R is equals to rho L by A. Okay, this is rho L by A. Okay, and if I talk to you that what is resistivity, so this is the resistivity. So it is R into L, sorry, R into A by L is equals to resistivity. Okay, now if I talk about that, what is resistivity? If I take this value as 1 meter square and this length as 1 meter, so you will get the value of resistivity as means this time the resistivity will become equals to the resistance. Okay, so it is the resistance. It is the resistance that is offered by a conductor. What is resistivity? It is the resistance offered by a conductor having a cross-sectional area of 1 meter square and length 1 meter. So when you have a wire whose cross-sectional area is 1 meter square and length is 1 meter, then during that time, whatever the resistance it is offering, then this resistance is considered to be as resistivity. Okay, this is similar to you that if you went to the market, okay, if you buy some apples, okay, and you ask the shopkeeper that what's the rate for the 1 kg apple, so he tell you 100 rupees per kg. Okay, 100 rupees per kg. If you buy 5 kg apples, then how much you have to pay? Tell me. If you buy 5 kg apples,
500.
500 you have to pay, na? You have to pay 500 rupees during that time. Okay, but is the rate per kg change if you buy the 5 kg apples?
No.
No, it will remain same, na? So what is resistivity and why does it does not change when you stretch the wire, when you fold it down, when you having stretching it, when you are tripling it, when you are doubling it? Why does the resistivity do not change? Why the resistivity remain constant? Why we say that resistivity is independent on the length and the cross-sectional area? Because it is fixed. Like the rate per kg is fixed. Whether you buy half kg apples, whether you buy 5 kg apples, the rate per kg is fixed. If it is 100 rupees per kg, it means this is the price when you buy 1 kg apples. If you buy 5 kg, you have to pay 500. If you buy half kg, you have to pay only 50 rupees. Okay, you understood? Understood? So this is the way why the rate per kg does not change. Sorry, the resistivity does not change, because actually it is the resistance offered. Okay, it is the resistance offered by a conductor when it is going to have uh, resistance, means we can say that it is the resistance offered by the conductor when its dimension is 1 meter square and length 1 meter. So that is called resistivity. You understood? That is called resistivity. So resistivity, note it down. What is the difference between resistivity and resistance? It is the resistance offered by a conductor, offered. It is the resistance offered by a conductor, offered by a conductor when when not having cross sectional area, having cross sectional area area 1 meter square and length 1 meter. Okay, note it down, please. Note it down. Done. So it is the resistance. That's why if you took the if for example if you took a copper wire and we just check it at that standard unit, that like the boiling point, like we have a fixed value na, water boils at 100 degrees Celsius. So we have measured that when we have 1 atmospheric pressure, then the water start boiling at 100 degrees Celsius. So it is its boiling point. It is, but can't the water does the every time water boils at 100 degrees Celsius? No. When you decrease its atmospheric pressure, then it can boils at 40 degrees Celsius also. So similarly, we have a standard unit. We have, like we take the copper wire, okay? And copper wire, we measure that if we are having a wire which is having a cross-sectional area of 1 meter and length 1 meter square, then during that time, what is it, what the resistance that is it is offering during that time when we are having 1 meter length wire and its cross-sectional area is 1 meter square, then it, whatever the resistance at this time it gives you, we will write that copper's resistivity is this. We'll write it. Then we take the iron wire and we put iron, same length, same cross section area. We find that iron is offering this resistance and we take it that this is the resistivity for the iron. So if you stretch the wire, it does not mean that you are now you are just calculating its resistance, because you are not having its standard unit. That's why resistivity does not change. Resistivity is only calculated when we have the conditions that its length should be 1 meter and length and the cross sectional area should be 1 meter square. Otherwise, if you are calculating it, it will not be considered. If you are not having this dimension and you want to calculate its resistivity, it is not the resistivity. That time you are just calculating its resistance, because resistivity has fixed dimensions. Length should be 1 meter of the wire and the cross sectional area should be 1 meter square. During that time, whatever the resistance it is offering, that we will say that it is the resistivity. That's why it is independent on the length and the cross section area. It depends on the nature of the material. Why? Because different materials at the same dimension offer different resistance. Like if you took the copper wire, it will same area and same cross sectional area and same length. It will provide you difference in the, I mean, there will be difference in the copper and iron wire. If you have the same wire of 1 meter square and cross sectional area and 1 meter length, so they will be having different resistance. So it depends on the nature of the material. Now you understood? Understood?
Yes, sir.
Is there any doubt? Is there any doubt that what is resistivity? And it is also called specific resistance because it is having some specific conditions. Okay, got it?
Yes, sir.
Let's move to the next question of this one. Just a minute. This NCRT exemplar questions are very important. Every student is requested to please do these questions, okay? Because NCRT examples build your means it just enhance your brain, okay? So whenever you do such type of questions, it will definitely going to help you, okay? So it is my request that everyone should do this such type of questions, okay? Next. After this 21, which questions I given you? Then I give you 28 and then 30 and then 34 and then 35. 28. 28. Question number 28. Yeah. Read the question number 28, please. Read the question number 28. And do this one. They are the bulb B1, B2, and B3 are three identical bulbs and connected as shown, okay, in the given figure. These are the identical. Identical means same resistance. Means identical bulb means same resistance, okay. When they are connected, they glow and they the current they are taking is 1 ampere, okay. The word identical plays a very important role, dear students. Let me explain you that the word identical means that if you have three resistors like 1 ohm, 1 ohm, and 1 ohm, okay, and now they are connected in parallel, that they are 1 ohm resistor, or you can, these are identical, you can assume 1 ohm or 2 ohm or 3 ohm, it's your choice. They are all identical. So whatever the equivalent resistance they are going to have, you know that in parallel, the potential difference remains same. The potential difference remain same. Okay. So the potential difference, okay, will remain same. But you know that the current divides. Okay, current divides. So if it is 3 ampere current, okay, then 1 ampere current will go through it, 1 ampere will go through it, 1 ampere will go through it, because it is identical. Identical questions solving problem is very easy, identical with identical resistors. But if suppose if you have a 2 ohm resistor and a 5 ohm resistor, 2 ohm and 5 ohm resistors in parallel, okay, and you have 2 ampere current here, 2 ampere current. So it does not mean that 1 ampere current will flow through it, 1 ampere current flow through it. No, it will not. Now these 2 ohm and 5 ohm resistors are not identical. So it will not be equal, the current will not be equally divided, because in parallel, you know, current divides, na? So the current will not be equally divided here. Okay, you understood? Here, the current will not be equally divided. Why? Because these are not equal resistors. So the one which opposes more, the less current will go through it. So you know that 5 ohm resistor will is the great opponent of current than 2 ohm resistor. So the more current will flow through this 2 ohm and less current will flow through this one. Okay. Got it? Got it?
Yes, sir.
Okay. But in identical, it is very easy. 3 ampere we have, 1 ampere to this one, 1 ampere through this one. If we have, suppose if instead of, if we have 6 ampere, then it will be 2 ampere through this one, 2 ampere through this one, and 2 ampere through this one. The same current will go because of equal resistance. If we need to divide and they are equal, then the same current will flow. Okay. Now read the question, please, one more time. Here it is saying that the 3 ampere current is flowing. Means total 3 ampere current is going. So we can assume that these are the identical resistors. So 1 ampere will flow through this one. Okay. Because these are identical. So 1 ampere will flow through this one, 1 ampere will flow through this one, and 1 ampere will flow through this one. Okay. Now you know that when we have 3 ampere current here, 1 ampere grow through this one, 1 ampere grow through this one, 1 ampere grow through this one. Then the total again, they will be added here. The all 3 ampere current will be added here again. Then the circuit, it will be 3 ampere here. So 1 ampere will come through this part, 1 ampere will come through this part, and 1 ampere will come through this part. And again, they will compute 3 ampere current again. So it is saying that what happened to the glow of the bulb when the B1 bulb get fused? Tell me. Tell me. If the B1 bulb get fused, then what will be the what is going to happen? Tell me. Tell me.
The other bulbs will not get affected.
Okay, so here you need to understood that uh, if the if we have 3 ampere currents, and if this B2 bulb, sorry, B1 bulb get fused, so the no current will go through this one. So let it be. The potential difference will be same now. Let me explain you there on the sheet. Okay, just a minute. Let's have this one. Okay, let's suppose it is saying that we have 3 identical bulb, B1, B2, and B3. Okay, and they are having 3 ampere current is passing through it. 3 ampere current. Okay, this is 1 ampere. Then 1 ampere will pass through it. 1 ampere will pass through it. Now it is connected in parallel. And this is a 4.5 volt battery. 4.5 volt. So you know that in parallel, the potential difference exactly remains same. So because these are the 3 resistors and they are connected in parallel, so whatever the value they are going to have, they will all receive the same potential difference. This is also 4.5 volts. This is also 4.5 volts, and this is also 4.5 volts. So if this bulb or any bulb get fused, any bulb, the other bulb will remain, keep glowing. They will not be affected because the current is 1 ampere here. The 1 ampere current will still be going through this one. And the total, if this bulb, let's suppose this bulb get fused. Okay. So the 1 ampere current from this one will be blocked. And the total current of the circuit will be 2 ampere now. 2 ampere. Because 1 ampere will come through this one and 1 ampere will come through this one. It does not mean that this time, because we are having 3 bulbs, so we are having 3 ampere current. So this time, since once bulb get fused, so the current will increase. Now this time 3 ampere current will be divided in 2 parts. No, no, it is not true. Dear student, you need to concentrate here that if we have if we have 2 bulbs only, then in parallel, if the current will decrease to 1 ampere, not the 3 ampere. It will not remain 3 ampere. It is just similar that if you switch off your AC, does it means that the electricity bill will comes with the same that you are using the AC? No. If you switch off, that's the current will stop going through this and the overall load will decrease. It's the same thing. So if you switch off a bulb, or if the bulb get fused, then why you need to pay for this one if you are not using? The same, the current will not flow, the current will decrease. So if this bulb, one bulb get fused, so it does not mean that if we are having 3 ampere current, so if they are the they are the 3 resistors, okay, and if they are connected with 1 ampere here, 1 ampere here, 1 ampere, 1 ampere, and 1 ampere. So if this fuse, it is still the 1 ampere and 1 ampere current will flow through it. It does not mean that it will add up and total. Now this time they have to 1.5. And if this bulb also get fused, so all the 3 ampere current will pass through the single resistors. No, it is not. Only 1 ampere current will flow through it. So if you are just concentrate here, that if you are adding something in parallel, it is not going to affect. If you are adding or subtracting, means removing, it will not going to affect the individual. The overall load of the circuit will increase or decrease, but the individual resistor will not going to affect. Let me explain you that we have 2 types of question here, that both the NCERT example question I'm going to discuss here. Okay, one question in the previous question we have this is a just a minute, I'm just coming back. Okay, so here we have a question, and you need to understood here. Okay, let suppose this is a 5 ohm resistor and this is another 5 ohm resistors. Okay, and they are connected with a let's suppose they are connected with a 10 volt battery. or 220 volt, that it is 220 volt. Okay. So if I connected, and now you can imagine that what is the current in this, you can imagine that this is the 10 ohm. The equivalent resistance is 10 ohm. So the current in the circuit would be, the current in the circuit will be how many? 22 ampere. Okay. V is equals to I into R. So I is equals to V by R. 220 divided by 10 will get 22 ampere. So 22 ampere will goes through this one. 22 ampere will this one, this one. And if you even have this, let's suppose you are having four resistors of still 2.5 ohm, 2.5 ohm, 2.5 ohm, then the current will still remain same because the total resistance is not changing. Okay, the current will still remain same, that is 22 ampere. Okay. Now, if you are connecting a parallel, let's suppose you add a 10 ohm resistor here. You add a 10 ohm resistor here. 10 ohm resistor here. So it means that it is not going to affect the current of this one. It will still remain 22 ampere, but extra 22 or is being added. Extra 22 ampere will also be added. And the total current of the circuit will become 44 ampere. If you are adding one more 10 ohm resistor, 10 ohm resistor, then extra 22 ampere is also added. So this will remain continue if you keep on adding. If you keep on decreasing, the total ampere of the circuit will increase or decrease, but the individual will remain same. If it is 20, if it is getting 20, the other will not be affected. If you are connected in parallel, mark my point, if you are connecting in parallel, no, if you are connecting in parallel, then the no effect of the current will take place in the, like it is similar that if you are turning off a fan in your home, because you know that in homes all the appliances are connected in parallel. So it does not mean that if you turn on the AC, then the voltage will drop to the other. Yeah, in starting it can easily, it can take a minimal change. Okay, but does not mean that it will that other substance or other appliances will not start working because all the current is taken by the AC. It does not mean they all will receive the same current and same potential difference because they are connecting in the parallel. Okay, got it? Got it, everyone? So here there are two questions that let me show you that you are going to have. Okay, and there are two questions here. Let me show you. Okay. One question is this one, 26. This question I was discussing. Okay, this was connected with 10 volt battery. I just took 220 volt. Okay, two 5 ohm resistors. One is this one. When you solve it, it is saying now if the resistance 10 ohm resistors is connected in parallel with the combination, will it means to this question number 26, you will get the same answer. Okay, so the total current of the circuit will increase or decrease, but the individual resistance current does not increase or decrease. Okay, got it? Same condition for this one. Okay, here if it is saying that what happens when the to the reading of A1, A2 and A3, tell me what happened to the reading of A1, A2 and A3 when the bulb and A, when the bulb 2 get fused. So bulb 2 is getting fused. Huh? So A2 will reading will be 0, A1 will be 1 ampere, same. This will be also 1 ampere. And this A3 means previously it was reading 3 ampere. Now it will start reading 2 ampere because one of the bulb get fused. Okay. Everybody understood? Tell me. Madiha, Kiran, Charisma.
Yes, sir.
And you, Shweta, you understood?
Yes, sir.
Okay. Now, same condition. how much power is distributed power when all the three bulb glow together. So power is very simple. Power is simply added. So you know that power is equals to 4.5 volt each of the is going to receive, and total current in the circuit is 3 ampere. So power is equals to VI. So that is V is 4.5 and ampere is 3. You multiply, you will get 13.5 watt. Got it? Got it?
Yes, sir.
If I ask you that what is the power of individual bulb? What is the power of individual bulb? Can you tell me? What is the power of individual bulb? Hmm? Power of individual bulb.
It's 4.5.
4.5 volt, because you know the P is equals to V into I. The voltage each of the bulb is going to receive is 4.5 volt because they are connected in parallel. And the current each of the bulb is going to receive is 1 ampere. So it would be 4.5 watt. Okay. Got it? Got it?
Yes, sir. Yes, sir.
Then after this one, we have 30. Question number 30. States Ohm's law and how it can be verified does hold true in all conditions. Tell me. Does it hold true in all conditions? Tell me. Tell me, dear students, will it hold true in all conditions?
When physical quantities like temperature is constant.
Yeah. So we know that Ohm's law state that at constant temperature, pressure, and other physical conditions, the current flowing through the conductor is directly proportional to the potential difference. Okay. So I is directly proportional to V. But okay, but at constant temperature, if the temperature is changing, then it is not true. So this will not hold true if the pressure and the temperature changes. Okay, got it? Got it?
Yes, sir.
What is the electrical resistivity of the material? You can explain it. That it is a resistance offered by a conductor having unit area and unit cross-sectional area and unit length of unit length. Unit means 1 meter square. Okay. Describe an experiment. You can SI unit, ohm meter. You can see that why it is having a unit resistance as ohm meter. Resistivity unit is ohm meter because you know that R is equals to area upon okay. So you know that you give R and 1 meter square upon 1 meter. So this and this will cancel out each other and this will be ohm meter. Got it? That's why it has unit ohm meter. Now moving to the next part. Here. Next question I give you is 35. Question number 35. 35. All of them, this is a simple question. Will you able to do this question number 35? Tell me fast. 35. So here you can check that effective resistance of the two resistors. What is the effective resistance? Hmm? This will be 8 and 8, 2 ohm. This will be 4 ohm resistors. Effective resistance. Got it?
Yes,
Why are you
sir.
not replying? And this one, the current flowing through 4 ohm resistor. Through 4 ohm. Jovita, tell me what is the current flowing through the 4 ohm resistor? Jovita, are you there?
Yes, sir.
What is the current flowing through the 4 ohm resistor? It will be 1 ampere. Why? Because this is the 4 ohm. Okay. And you know that this is the potential difference, 8 volt battery. Don't consider that this is a 8 ohm to resistor. Just consider this is a 4 ohm because equivalent of this one is 4 ohm. Okay, two 8 ohm resistors connected in parallel. Okay, so 8 ohm, 8 ohm. So it means it is 4 ohm. Just assume this is a 4 ohm. So one 4 ohm, you can imagine here or you can write it here. Same it is 4 ohm. Another is also 4 ohm. This one is here. Okay. So now you know that in potential, these are now equivalent resistor. Na? So this is very simple that if the resistors are same, then in series the current remains same, but the potential difference divide. So it is 8. So 8 will be divided into 2 equal half because they both are same. So it will be 1 ampere, sorry, 4 volt, and this will be also 4 volt. Okay, the both will be receiving 4 volt because 4 volt to this one, 4 volt to this one. This will be added to as 8 volt. Or you can do another thing that you can calculate the equivalent current first in the circuit. You can calculate the equivalent current that I is equals to V upon R. V equivalent is 8 and R equivalent, the total resistance of the circuit is 8 ohm. So you get 1 ampere. So 1 ampere current will flow through it. 1 ampere current will flow through it. It will remain same. Now for this one, you can calculate the potential difference. So V is equals to I into R. I is 1 ampere and I is 1 ampere and R is, for this one it is asking 4. So it will be 4 volt. So it's your choice. You can do it directly or you can do it like this way. Got it? Got it?
Yes, sir.
Yes.
Next, the potential difference across 4 ohm resistor. We have done this one. Okay. Current through 4 ohm resistors will be 1 ampere. Okay. Because like let me tell you one thing that current is always taken when there are one or more means resistors are connected in series. Okay. Then it is always equivalent current is taken. Okay. We have a question in the NCRT also. Let me show you here in the NCRT. Here, let me show you that in this question. Here in question number 9. Question number 9, what it says? The 9-volt battery is connected in series with this one, this one, this one, and this one, and 12 ohm. How much current is in the 12 ohm resistor? So it does not mean that you start calculating in 12 ohm. You will write that V is equals to IR. So it is asking for I is equals to V by R. So it is saying 9 volts. So you write 9 by 12. It will be incorrect. It will be considered as incorrect. First of all, you have to calculate the equivalent resistance. What is the equivalent resistance? If there are n number of resistors are connected, don't treat it they are different. Treat them as a single, whatever the value they are going. So it will be 13.4. When you added 2 plus 3, 5 and 0.51, and this 1.4 and 12, 13.4. And the 9 volt is given to them. So